Welcome everyone. I am Subhash Chandra, our first year in mechanical department. So we are going to see about application of mathematics in roller coaster. So introduction. Mathematics is a science that deals with logic of shape, quantity, and arrangement. And as we all know, maths is all around us and in everything we do. So it is a building block for everything in our daily lives and it's a stepping stone also. So it includes mobile devices, computers, software, architect, and so on. So the basic mathematical subjects such as calculus help us to determine the height needed to allow the car to get up the next hill. So through this, roller coaster rides are designed to look and feel more dangerous than they are. So the riders still get the thrill without significant risk. So this is a picture of a roller coaster as we have seen in many theme parks. So roller coaster it involves a less G-force on the rider's upon entrance to the loop than a circle. And it will still guarantee the acceleration necessary to get through the top of the loop. Areas of mathematics such as numerical analysis and differential equation help solve the physics and engineering problems that arise as roller coaster designers. Slope. Designers first sketch a roller coaster showing the placement of the hills, twists and turns. Then they have to make a more technical drawing in a computer-aided design called a CAD program. This is where math becomes important. They have to calculate the slopes of our roller coaster hills in order to construct an accurate model. And also slope will allow us to accurately determine the speeds that are generated at various points along the track. So what are loops? The most exciting roller coaster designs contain one or more loops. The loops must be built with extreme precision. A loop that is too circular will require very high speeds. This will result in a G-force that is too high for people to comfortably withstand. So the loop with higher gravitational force will be uncomfortable to withstand. A perfect roller coaster loop is teardrop shape called a rothoid loop. This means the roller coaster car can get through the loop at lower entry speeds. Advanced math functions are used to model rothoid loops in computer programs. Speed. In order to complete a loop, a roller coaster car must travel at correct speed. Speed that is needed is dependent on the size of the loop. Every roller coaster begins with a very high hill. The higher the hill, the greater the potential of stored energy of the roller coaster car. As the car reaches the bottom of the hill, the potential energy has been completely converted to kinetic energy. So in designing a well-functioning roller coaster is considered the following. For a well-designed and functioning roller coaster, we must consider the speed, velocity, acceleration, slope, maximum height and minimum height. So what is the importance? The safety and amusement of the riders. Without calculus, roller coasters would not be able to complete its course safely nor efficiently. Engineers constantly use calculus when designing the loops and curves of the roller coaster. So the calculation parts are by using calculus, engineers can use the height and slope of the point to calculate the speed. These calculations are used for safety regulations. Engineers have also used speed and velocity equations to calculate the maximum and minimum heights attainable by a roller coaster. So the calculus applications. Engineers carry out calculations such as finding the velocity at the maximum heights of loops to see its gravitational force is safe or not. If you see this diagram, you can see that many loops are there, many curves which is very height, which is of more height, and many bottom slopes, parabolas are there. So speeds in calculation applications. Acceleration and velocity of the coaster are also very important. Take derivative for velocity, take derivatives again for acceleration. distances. Maximum height of coasters are measured using calculus, and it can be found as slope goes from positive to negative. So this is the example for this above explanation. So at the conclusion, we find acceleration at we find speed, velocity, and maximum height of this slope. At conclusion, calculus is very crucial part of designing a roller coasters. It is used to notify engineers of speeds, velocity at many different points along the track. So these are the mathematical questions which is needed to be done for roller coasters. We integrate, we use calculus, we differentiate many things. We differentiate accelerations, we do distances for finding maximum and minimum heights. This is the equation for the first parabola. The x-coordinate of the vertex of the downward opening parabolas is at the middle of the x-coordinates. By many calculations we attain at these rates, and finally we are grouping a solving for x and substituting in 7th and 6th equations. Conclusion: accurately model every component of roller coaster design. A branch of math called calculus is needed. Calculus is used to create and analyze curves, loops, and twists along the roller coaster track. It helps with slope calculation and finds the maximum and minimum points. Thank you.